Hi guys, and welcome to another video lesson. Today's video lesson we're going to be looking at Euclidean geometry, proving that two triangles are similar and finding the length of one side of a triangle. The question that we are going to be looking at is from the February-March 2018 examination paper. The question reads as follows. Question 9 says, in the diagram, DEFG is a quadrilateral with DE equals to 45 and GF equals to 80. The diagonals GE and DF meet in H. GDE equals to FEG and DGE equals to EFG. First thing that we need to do is to make sure all this information is on our diagram. And we can clearly see that our angles here are given. GDE is equal to GEF, and we got DGE is equal to EFG. There's the symbols are quite straightforward. Now, they also tell us that DE is equal to 45 and GF equals to 80. So all done. Let's go read the question. It says, give a reason why triangle DEG is similar. Now that is the symbol for similarity. Give a reason why triangle DEG is similar to triangle EGF. Now, there's two reasons why triangles can be similar. Number one is if they are equiangular. Number two, if their sides are in proportion. In this particular case, we can see that DEG, DEG, we've got following angles. Angle D is equal to, in triangle EGF, EGF. So all we need to show is two angles in one triangle equals to two angles in another triangle. We've got these two angles here, DGE, and there's the other one. Now, let's look very carefully. DEG, there's it there, and EFG. So we also have a remaining angle, and let's put that in. So let's call that X and X. So therefore, the two triangles are equiangular. So our reason will be for just one mark, 9.1, we'll write equiangular. Equiangular, angle, angle, angle. Let's look at the next question. Calculate the length of GE. So let's look at that. The length of GE. So they want us to find this particular length of the side here, which is GE. Now remember that if two triangles are similar, their sides are in proportion. You just need to write that down very quickly. So we got triangle DEG is similar to triangle EGF. So for 9.2, let's write down the sides in proportion. So let's just write that down. Triangle DEG is similar to triangle EGF. And we've showed that in the previous question. Well, they told us to give a reason why these two triangles are similar. Therefore, let's write them down with their sides in proportion. So we'll say DE all over EG. Remember, first two letters over first two letters. Because the triangles were named with their angles in that particular order. Then it'll be the next two letters, which is EG all over GF. Then remember, first and last letters over the first and last letters. So DG all over EF. Now let's determine which sides are given and which side we need to find. Well, we need to determine the length of GE. Therefore, GE has to be a part. So EG, GE, so it's here and here. So we've got EG. And what do you notice? DE and GF. DE and GF are given to us. So the lengths of those sides are given. So therefore, this would be fairly straightforward calculation. EG times EG is EG squared equals to DE times GF. Let's substitute. DE is equal to 45 and GF is equal to 80. Therefore, we can conclude that EG will equals to the square root of 45 times 80. Let's put that in our calculator. Square root of 45 times 80. 60 is our solution. So that's 60 units. Let's go update our diagram. So EG is 60. So therefore, there's EG. This whole length of this side of here is going to be equal to 60 units. Let's go and do the next question. Prove that triangle DEH is similar to triangle FGH. Now, let's go look at DEH. So we got DEH. That's as follows. And our other triangle is FGH. So we got FG. So let's just quickly go and highlight that. Right, so what do we notice here? Remember that these triangles are given in the order that their angles are equal. So therefore, there is a relationship between D and F, between E and G, and H and H. So let's look at that. So if you look at it very carefully, from the previous example, we can now say that DEH is equal to HGF because that was triangle DEG is similar to triangle EGF. Okay, so we know that. What's the other thing that we know? We know that these angles here are vertically opposite angles, and remember, vertically opposite angles are equal. Okay, so therefore let's look for another symbol. Okay, so we've used the cross, so maybe let's just put a tick and a tick there. Right, so those two angles are equal to each other, and also we can conclude that let's put a circle there and let's put a circle there. So those angles are also equal to each other. So therefore, our reasons here will be vertically opposite angles, DHE equals to GHF, vertically opposite angles. Then we'll say DEH, remember that's from the previous example, is going to equal to HGF. And then we'll say HDE equals to HFG, remaining angles. So we've got our three statements. Remember, we only need two with reasons. Let's go write that down. So in 9.3, remember, we always start off our proof by writing in triangle DEH and triangle FGH. So you just copy that down. In triangle DEH and triangle FGH, our first statement will be that DHE is equal to GHF, vertically opposite angles. GHF HF, and our reason will be vertically opposite angles. Our second statement will be that DEH is going to equal to, so remember the cross and the cross, H, G, and F. It's HGF. HGF. Why is that so? Because remember now in 9.1, when we updated our diagram, for similar triangles, it was given to us here that triangle DEG is similar to triangle EGF. Third statement here will be, remember the circle and the circle, so we're going to say HDE is going to equal to HFG. HFG. And our reason there will be remaining angles. Therefore, what can we conclude? Therefore, triangle DEH is similar to triangle FGH, and our reason will be angle, angle, angle. Those two triangles are equiangular. Let's go look at our next question. Hence. Hence means we have to use what we derived in our previous solutions. Calculate the length of GH. So GH, let's go look at GH. So therefore, we want to find the length of the side here, which is GH. All right. So first thing that we're going to do is let's write our sides in proportion. So for 9.4, remember that DE, first two over first two, F, G, second two letters over the second two letters, EH, all over GH equals to first and last, so that will be DH, all over FH. And that is because we've just proved that triangle DH is similar to triangle FGH. Now what do they want us to find? Let's go look at that very carefully. So they want us to find GH. So therefore there's GH here. And what else are we given? Well, as you can see, we are given GF and DE. So GF and DE. So therefore we'll have to write this down. So let's write that down. We'll say DE all over F. G equals to EH all over GH. And let's make what we're finding the subject of our equation. Remember, we are finding GH. Let's write that down. So therefore, GH is going to equal to, so GH times DE is going to equal to F G times EH. So therefore, GH equals to F G times EH all over DE. So we've got F, G, E, H, and D. So let's go look at our diagram. So we've got F, G, got D, E. Now let's look at DH. If you look carefully here, we've got F, G, E, H, and D, E. So herein lies a slight problem for us. EH, we don't have the length of EH, and there's EH here. But what we do have is that GE is equal to 60. And we've got GH, which we want to find. Now we need to write HE in terms of 60 and GH. If you look at it very carefully, what can you tell me about GE? GE, this whole side, is going to equal to GH plus HE. Therefore, what can we conclude? GE is equal to 60, and we've got GH, which we want to find, plus HE. Therefore, we can conclude GH. So HE is going to be 60 minus GH, the side that we need to find. So therefore, HE equals to 60 minus GH. Let's write that down. So we'll say that HE equals to 60 minus GH. Let's substitute. So we got FG. What is FG equals to? So we got FG is equal to 80. 80 times, let's substitute, HE is 60 minus GH all over DE. D is equal to 45. So we got 45 times GH is 45 GH. 80 times 60, that will be 4,800, and 80 times GH is minus 80 GH. So we're going to get 45 plus 80 GH equals to 4,800. This will be 125 GH equals to 4,800. GH equals to 4,800 all over 125. Let's just quickly put that in our calculator. 4,800 all over 125 equals to 38.4 units. Therefore, we can conclude GH is equal to 38.4 units. That is, if you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics, and also you can check out all the videos at jlmaths.com. And I'll catch you in the next video.